Hey, geometry class. This is the first lesson of starting to go online learning. For this first section that we do, I'm gonna just uh, do the video, and within the video, I'm gonna try to embed some questions, kind of like what your warm up, that 2-minute video that I assigned the other day. So kind of be prepared for that for this video. What I'll probably do is we'll go through an example and then I'll embed a question into the video for you to kind of practice and answer. And then there won't be too much for this section anyway, too much homework outside of that. So, that's just kind of how this first video is going to go. We're just going to kind of ease into it. So just be prepared for that. So here we go. What you will need is, let me get hooked up here. What you will need is, I sent home with you these notes for section 8.1 because we're going to start chapter 8 now. That's just kind of the easiest way to start with a clean, fresh chapter. So we're going to start with section 8.1, and 8.1 is fairly short and sweet. They're talking about geometric mean, and a geometric mean, when we are like working with proportions, what they will do is sometimes they'll have like two values for A and B. So A and B would be numbers in this case. And then they would have two unknown values that are the same value, and they're both labeled as X in this case. So like let's say A and B are, I don't know, the numbers, 5 and 9. Okay. So we would have 5 over X equals X over 9. And what we would do is we still would cross multiply. And so we would have, in this case, x squared equals 45. And then we would take the square root of both sides to get rid of the square. And x would be, I don't know, whatever the square root of 45 is. I am going to have you guys go ahead and work these out with a calculator. And then just give me like one decimal place. So let's see, the square root of 45 is 6.7. So go ahead and just round to one decimal place. 45 does live in between 36 and 49, which would be between 6 and 7, closer to 7 than it is to 6. So 6.7 is what that would be. So basically the geometric mean, when you're doing this and when you have two values of x that are this, like your two variables are here across from each other, you're just always going to end up taking the square root of these two multiplied together. So multiply those two, and then to get rid of the square, you would take the square root. So it's as easy as that. Down here, when we actually start doing like example 2, we'll see an example of when the geometric mean is kind of used. But for right now, they want us to do the geometric mean between 8 and 10. So that would be kind of like saying x over 8 is equal to 10 over x, or vice versa. You could do 8 over x equals x over 10. We would cross multiply. So x squared would be 80. And 80 lives between, let's see, 80 lives between 64 and 81, right? 64 and 81. So this would be like 8 squared, and this would be 9 squared. So if we're kind of thinking about how that would work into our calculator, we're looking at a number that's 8 point something, some number close to 9, right? 8 point something when we take the square root. So the square root of 80 is 8.94. We'll just call it 8.9. Okay. All right. If we move on, let's see, theorem 8.1. When you're looking, they will give you a triangle that looks like this, and they will tell you that all of the triangles within that triangle are similar to each other. Okay. There's actually 3 triangles that are associated in this picture, and we've kind of talked about that before. You'll have a small one here, a medium one here, and then the overall large one on the outside. Okay. And notice that all of them have a 90-degree angle. So what I will tell you to do is, when we are doing stuff like example 2 and when they start to put numbers in there, go ahead and write each one of the 3 triangles out, the small, medium, large, and then it can be easier to compare them. So I'm going to do that: small, medium, and large. Okay, so the small one, I'm going to face them all this direction. Okay, large, like this guy. Okay, here I'm going to put my 90-degree angle. in the bottom left corner, and there he is. Okay, now they just want us to label the vertices. So this is the small triangle that I'm looking at, this guy right here. So the 90-degree angle maybe is where you want to start. That is at J, okay? And then G is going to be the tall side. So it's J, G. G is the tall side. F is going to be the bottom side, and that completes that medium or that small size triangle, okay? For the medium size one, here's my 90-degree angle, but I'm looking at this triangle here, okay? J is going to be the 90-degree angle. H is the tall side, and G is the bottom side, okay? For the large triangle, the overall outside one, G in that case is my 90-degree angle. My tall side is H, and F is my bottom side. Okay, so that's kind of one way of doing that. Then they want us to write a similarity statement. Okay, so basically I'm looking for triangle. I'm going to do this in a different color. Triangle. I hope you guys all brought your pens home, you geometry crazy gurus that have to have your colored pens. Triangle, let's just go G, J, F, if I go in that order. So G, J, F, top, right angle, right side, is similar to triangle. If I go in that order, this one would have to go H, J, G, and that's similar to triangle, H, G, F. Okay, so something that looks like that. This bottom diagram here, I'm not going to talk too much about it, but it basically says after you've separated them out into the large, this one would be the small, and this one would be the medium, what you can do is you can set the sides over top of one another. So I could say like B over X would be the same thing as C over B. You know, I could say B over X equals, no, yeah, B over X equals C over B, and then I could cross multiply. And there, that again is like that geometric mean, because I'm going to end up with B squared equals, you know, whatever that number is, CX. And then I can solve for things, okay? They will give us actual numbers instead of giving us X's and B's and C's and all that good stuff. But you can set up each one of the sides into a proportion, okay? Flip over to the back side, and we've got a couple things going on here. So here's when you might use geometric mean for this diagram. If I'm just looking at this, let's see, this is technically the small triangle. I'm going to put him in the same order he is right now. So small is this guy. There's that right angle. But I'm going to label his two sides that he has. So he has X is here and he has H is here. Okay. Then if I flip over to this triangle, this medium size one, I'm going to turn him right side up so that he's facing the same direction as the small one. Okay. So I've just taken this guy and kind of like flipped him up so that he's sitting this direction. H will be the bottom side and Y will be the right side. Okay, so what I can do then is set up a proportion where I have, like, let's say X over H is equal to H over Y. And then I can do my cross multiply, and again I'm going to end up with like H squared equals XY. So that's that geometric mean where I'm going to end up taking the square root. Okay, same thing here. I can set this one up into like a medium and large or small and large and set up my proportions that way. Now they do have this third side or that long side labeled as C. Or if they didn't have that labeled as C, you could call that like X plus Y, because that's X and Y together. So just depending on whether you're given numbers or variables, you might want to label it differently. Okay, so let's go down to example 3, and they say find X, Y, Z. That's all the instructions that they give us, and then they give us this thing. Okay, I really, really encourage you to draw out what each one of them looks like. It's not going to take very long, but it'll be easier in the long run. Okay, so small guy, medium guy, large guy. Okay, we'll face them this direction. You can face them another direction. It doesn't matter which direction you have these triangles facing, but make sure that they are all kind of facing the same direction. Then it makes it easier for them to compare. So I can either face them to the right or face them to the left, or I don't know, put them upside down, whatever. So find X, Y, Z. Another thing that I will tell you is that it doesn't matter what order you put the X, Y, and Z in, or what order you solve them in. Sometimes you will have to solve the Z before you solve the X, or vice versa. So Okay, let's go and label this guy. So if I'm looking at the bottom side here, his bottom side is going to be 5. X is going to be the tall side, and the hypotenuse side, or the one that's across from the 90-degree angle, is going to be labeled as Y. The medium size is this one here. His bottom side is X, okay? Now, we've kind of have him flipped around. So if we look at his hypotenuse side, the one that's across from the 90-degree angle, the 90-degree angle is right here, that is Z. So Z is actually this side. The tall side is going to be what 20 is. And then the overall large triangle is the one that we actually have in the correct order here, okay? The bottom side is Y, the right side is Z, and then we have to label this third side, okay? The third side is going to be labeled as not just 20 and not 5, but we have to add them together and make 25, okay? All right, so then we have to set up some proportions here, okay? So we look at X's and we look at Y's and we look at Z's, and what we need to make sure and do is we need to find, you know, some sides that basically we don't want to set up any proportions that we have X's and Y's all at the same time, or X's and Z's all at the same time. So we want to set up some proportions so that we're not solving for 2 different variables at the same shot, okay? So what I'm going to do is, if I look at, like, let's say we're solving for X here, okay? I've got an X here and an X here, okay? So I'm going to put one as a circle and one as a box, okay? So in this case, I'm only comparing the small and medium triangle. I'm not comparing anything other than that. So I have small, medium. X in this case for the medium triangle is going to compare to 20, and 5 is going to compare to this X, right? Okay, so I'm comparing small and medium, bottom side, right side, right side. Okay, so I can set that up as a proportion. Let's see if we run into any problems here. Okay, so I could go 5 over X, and I could go X over 20. Okay, now this proportion is kind of like a geometric mean problem. What we can do is we can take the X's, multiply them together, and take the 5 and the 20, multiply them together. That is, I think, 100. Take the square root. That comes out really super nice. So X is 10. Okay, now we didn't run into any problems here because we're not solving for X's and Y's at the same time. We only solved for X, so that was really nice. All right, so I'm going to put him there. And what I'm going to do is over here, I'm going to cross off the X's and I'm going to put 10s in there now because I know each one of those is 10, and I can use that to find any of the other things. Okay, so now I have Y's. I'm going to have to use that same pen again. I have Y's. I have a Y here and I have a Y here. So I'm going to do one circle and one box. Okay, so now I'm comparing the small and the large triangle. I'm like ignoring the medium one. So I'm going to put my finger over it. Okay, so Y in this case is going to be the same as 25 over here. This Y in this case is going to be the same as 5 over here. Okay, so that's kind of how I'm going to set this proportion up. All right, small and medium we're comparing. Okay, so kind of keep your finger over the middle piece, and I'm going to set up my proportion. So I have Y here on this side. I have 25 on this side. I have 5 over here, and I have Y over here. Okay, so I started going left to right, left to right. I want to make sure I do that same thing. Okay, now I could have gone Y over 5, so top to bottom equals top to bottom. That would work too. Doesn't matter, just as long as I go the same direction. Okay, now here we have that geometric mean again, so I have Y squared. 25 times 5 is going to be 125, and then I can take the square root. So the square root of 125 I don't think comes out nicely. It is going to be, I don't know, somewhere, I don't know, between 11 and 12. 11.2-ish. So that's what Y is going to be, about 11.2. Let's go ahead and round to 1 decimal place. Okay, so that was the Y's. Now let's do the Z's. Let's do one more color for Z. Okay, this one I'm going to go back. I'm going to go back to my green. So Z's, I have a Z here. I'm going to circle. I'm going to box. I've got a lot of stuff going on here. Okay, so in this case we have a Z here and a Z here. Okay, so like think to yourself, what triangle am I not going to use, or what triangle am I going to use? What 2 triangles? Okay, the small one is the only one that I don't have here that I'm using. Okay, so I have a Z here, Z here. Z in this case is going to correspond to the 25. Z in this case is going to correspond to the 20. I'm not using the bottom sides at all, right? So setting up your proportion, I'm just going to start with this Z on the left side, and I'm going to do Z over 25. That would be like medium to large, would be 20 over Z, medium to large, okay? Got a geometric mean again. Z squared equals, let's see, 25 times 20. Okay, I wanted to get my calculator out just now, but 25 times 2 is 50, and then with an extra 0 on it, right? Okay, so 500. If I take the square root of Z squared, Z is going to be, I don't know, whatever the square root of 500 is. 22.4. And that's what Z will be. Okay? All right, so just separate them out, small, medium, large, set up your proportions. If you ever run into a scenario where you have X's and Y's set up at the same time, just try to solve it, try to solve a different variable first. So maybe you're solving the Z variable first. Then you can use that to solve for X and Y, okay? All right, last one, almost done. All right, here is a story problem, and what's happening here, Zach wants to order a banner that will hang over the side of his high school basketball stadium grandstand. So here's the back side, and then they have like the bleachers and stuff here, okay? So he's wanting to hang a banner on this back side, all right? To find this height, he uses a cardboard square to line up the top and bottom of the grandstands. He measures his distance from the grandstand and from the ground to his eye level. So he must be standing here. Yep, he's standing here. And so he measures over eye level to the bottom of the grandstand. And he says that he is standing about 10.5 feet away from the grandstand. And he is 5.75 feet tall. Okay. Now, 5.75 feet tall, they might give that to you in feet and inches. 0.75 isn't 75 inches, right? 5.75, 0.75 of a foot would be 5 foot 9 inches, would be 0.75, right? Because 0.75 is equivalent to 9 over 12. So just kind of keep that in mind, that he is 5 foot 9 inches at eye level. So he might be like a little bit taller than that actually. But eye level is 5 foot 9 inches, or 5.75 is from here to here, okay? And then we're trying to find what X is. Okay, so if I'm looking at this, I still have my 3 triangles going on there, right? And what I want to do is I want to set them up so that I can solve for my X. Okay, and what I see here is that this small guy, I'm going to face him this direction. I'm going to face that small guy, that small triangle, in this direction. Okay, and here's my 90-degree angle right here in this corner. And I know that the bottom side is 5.75 if I have him faced that way. And this side right here is 10.5. Okay? And then I have a medium-sized triangle, which is facing exactly the way that I want it to on there. Right? It's just, I'm going to do that in a different color. It's this guy right here. And his bottom side is 10.5. And his right side is X. Okay? Now, if you notice, I'm only wanting to solve for X in this case. I don't even have to write out what the large side triangle is, because really I don't know very much about the large side triangle. But I have each one of the sides that I can compare, right? 10.5 goes with X, and 5.75 goes with 10.5. So I can just set that up as a proportion, okay? And then solve. I don't have to write out what the large triangle looks like, okay? 10.5 over X. And 5.75 over 10.5, and then I can just multiply, okay? So 10.5 basically squared, or 10.5 times 10.5, this side will be 110.25, and then I have equals 5.75x. And then to get the x, I'm going to divide by 5.75, I'm going to figure out how tall this banner needs to be. 19.2 feet, basically, okay? Find the height of the grandstands to the nearest foot. Okay, so here's the deal. We haven't quite answered the question. We know that the length from here to here, just from here to here, is 19.2 feet. Okay, but from here to here is 5.75, and they want the whole length of the grandstands. So if this is 5.75, we're going to add that to the 19.2. to get the entire length, okay? Try to do some of this in your head if you can. 0.95, I know is that as a decimal. And then this would be 24. So 24.95 feet. And there you are. Okay? All right, so hopefully that wasn't too long of a video. I'll try to have, you should have answered probably all the questions that I had, or you'll have one more question on the end of this. But there you go.